Okay, so we're going to continue with part 3, devices and electrodes. So we talked about contraindications and precautions, and now we're going to get into some specific types of current stimulators. So in the chapter, they had the introduction, they started talking about waveforms, and then blammo, they just went right into interferential current and Russian protocol before they even started talking about parameters. And I think that's a little bit confusing, so I put it more towards the end. So interferential current is an alternating current application. It uses 2 sine waves and a medium carrier frequency. One sine wave is at 4,000 hertz and the other one is at 4,100 hertz. They cross each other, and the out of phase results in a beat frequency that's the difference between the 2 carrier frequencies. So you get 100 hertz or cycles per second. And remember we said for amplitudes of variable frequency from 1 to 100 pulses per second. So with IFC, we're getting the effect of 100 cycles or pulses per second. And so what they call that is, with 100 hertz, you really can't feel 100 pulses per second. You can't feel each individual pulse. So you get what they call the heterodyning or blending effect. So it feels like one continuous thing instead of being individual pulses. If you turn the cycles per second or the frequency down to 10 pulses per second, you can feel each one. It feels like a tapping. And we'll talk about that in the pain management chapter and when we want to use that. So when you're at 100 cycles per second, you get that heterodyning effect that feels sort of like a continuous buzz. It's not really continuous, but it feels like that. There's no net charge, no net DC component, so no charge builds up under the electrodes. And that's what we want for the applications we're using it for. So there's no randomized control trial that says this, but it is thought that there's an advantage to the advantage to interferential current is that it may penetrate more deeply and overcome skin electrode impedance with less discomfort. So I like IFC. IFC is great. I don't know that it's any more or less comfortable than TENS. Usually IFC is a larger unit that you just use in the clinic, and TENS can be portable, so you can take it home. So, you have to decide what your advantage is. You can use IFC for sensory or motor stim if you adjust the parameters to do what you want to do. There's no difference in efficacy when it comes to pulse currents such as NMES or TENS devices. And really, a lot of times you're deciding on the difference based on convenience or availability or something that's portable. Or just some people just have their habits. They like one machine better than another. So those are there are advantages to using different ones, but there's no difference in efficacy. So you're going to get good effects from any device if you set the parameters right. So Russian stim is used for neuromuscular stimulation of large muscles. A lot of the muscle stim done in the clinic is done to quadriceps and tibialis anterior for dorsiflexion. Those are like the 2 most stimulated muscle groups if you look at the different studies, because quadriceps inhibition is really common after knee surgery, and knee surgery is really common. So we're doing that a lot in PT. If we're going to be stimming anything, we're going to be stimming that. Also, drop foot is really common, whether after orthopedic surgery or a stroke or something like that. And so we're using muscle stim a lot for dorsiflexion. So Russian stim, it's called Russian stim because it was developed by Russian scientists. It's a medium frequency stimulation. It has a 2500 hertz, you don't need to necessarily know all this, but a 2500 hertz alternating current carrier frequency. It's a sine wave, so there's no net DC component because it's biphasic. The phase and pulse durations are 2 to 400 microseconds. Look at that strength duration curve on page 227. You'll know that's the perfect pulse duration for stimulating muscle fibers. It does modulated bursts of 50 to 100 bursts per second. You think you can feel that? No, it feels like one continuous bzzz. It may generate a more powerful but comfortable muscle contraction. Your mileage may vary. Everybody feels things differently. Some people feel like Russian is super bitey and they like to use other applications. Some people love Russian. So try them out. We're going to try them all out in lab and see what you like. So Russian stim is used for motor stim, edema reduction, and joint range of motion facilitation. High voltage pulse current, you can use it for lots of things. It's often used for wound healing, tissue healing at the cellular level. There's a substantial evidence base for that. At the end of this PowerPoint, there are references talking about different levels of stim and different efficacy. In the muscle stim and pain management lectures, there are tons more references, so if you want to find some references, you can look through those and see what you like. High voltage pulse current is a pulsed monophasic. There's a twin peak and then a long interpulse interval. So you have high peak voltage and amplitude, short phase and pulse, and a long interpulse interval to let the charges dissipate, because there is a small net DC component, so you get a little bit of charge buildup. Some devices permit a long interphase interval as well as a long interpulse interval. So you have a big phase, long interphase, big phase, long interphase, then long interpulse interval. So the idea is you can use high voltage stimulation for the tissue healing because we're trying to change the permeability of cells. You can use it for sensory and motor stim and for edema modulation. Sometimes they use it during a painful procedure almost to distract someone. Like if they're doing sharp debridement or something like that, use high volt to distract them from that moment of pain. So it's not... There's one clinician in my clinic who uses high volt for pain management, for sensory pain management, but you don't see it very often in the clinic. We can look at it, but it's not a real common application. Unless you work in a wound healing clinic, and then you're probably using it all the time. So lots of other electrical stim devices, and we will have a bunch of devices, different ones that we will play with in the lab, so you can try different things and compare how they feel, and maybe develop your own preferences for the ones that you like. And then every clinic you work in, you're going to have different devices as well. So you'll get used to, but the idea is, what I really want you to get out of this class is that you can take any electrical stim device and make it do what you want. You are going to be knowledgeable enough to do that. That's my goal. So there are some things that have subliminal stimulation, so they're subsensory, you can't really feel them. Microcurrent. There's no efficacy that's been demonstrated for pain management or muscle retraining for subsensory stimulation, although there's a theoretical application for tissue healing, and there is some research in using it for PTSD, depression, insomnia. I have a microcurrent device that I will bring into the lab, and you can try it out, see what you think. Transcranial electrical stim is not generally done in PT. It's a pulsed monophasic at a high frequency with a low amplitude. It's used for central nervous system stimulation, but you cannot monitor central nervous system responses directly. So you'll see research out there for different uses for transcranial electrical stim, but we do not do it in PT, but you'll see stuff in the literature out there. So for electrodes, you need a minimum of 2 electrodes to complete a circuit. Sometimes a single electrode will be used There's this application where you're using ultrasound and e-stim together. You use a single electrode for the ultrasound and then, or for the e-stim, and then the ultrasound head is the other point of contact. You need a minimum of 2 points of contact to complete a circuit. So if one of the electrodes falls off, no current is flowing. You're not going to have a circuit. So that's probably the least dangerous situation if one electrode falls off. If one comes off partially, that's a little more dangerous because the part where the one that's partially off is touching has a higher current density, and it can cause a burn or skin irritation. So things with direct current, devices that do direct current, there's going to be a cathode and an anode. They're often color-coded. A lot of electrical stim leads are color-coded black and red. Black for the cathode and red for the anode. The color coding doesn't matter when you're using a balanced waveform because both leads, it keeps switching. It's biphasic. And so they serve alternately as anode and cathode, so the color coding doesn't mean anything. So when you're hooking up electrodes for balanced waveforms, which we're doing most of the time in PT, it doesn't matter which, the red or the black, you hook up to anything. I hope that makes sense. And we'll see that in lab. So electrodes are made of different materials. You could have metal with a sponge covering, and the sponge has to be water soaked because a sponge is not very conductive, but water is. You can have carbon silicone with a conductive gel. So the metal and the carbon silicone with the conductive gel, those are both sterilizable and reusable. You don't want to reuse them before you sterilize them. Silver chloride with conductive paste is usually used for recording electrodes like EMGs and EKGs, that sort of thing. What we see most commonly in the clinic for our physical therapy applications are the self-adhesive, conductive, disposable hydrocolloid polymer electrodes. And so when we get into lab, each of you will get some sets of electrodes that's yours. You do not want to use electrodes between two people. So you're going to use your electrodes on you, and somebody else is going to use theirs on them. You're not going to share electrodes. You see these most often in the clinic. And in our clinic, once we use a set of electrodes on a person, we keep the electrodes with that patient's chart. So if we are going to use them again the next time, we use the same set of electrodes until they wear out, and then we throw them out and get new ones. So electrodes have to be good conductor. There has to be uniform conductivity, and we'll talk about the consequences of non-uniformity in a minute. They have to be malleable so they can, humans are not boxes. They need to conform to the body. They have to be durable because you don't want them to wear out right away. Hypoallergenic because you don't want to irritate people's skin. They have to be easy to apply and take off. And they have to be either disposable or sterilizable. So most disposable electrodes have some guidelines on how many times you should use them. If you are reusing disposable electrodes, you should inspect them every time to make sure they're still intact. And only use them again with the same patient. You don't want to reuse them between patients. So the current density on an electrode is milliamps per centimeter squared. So how many amps are going through a certain area? So the current density is the amount of current that's concentrated under an electrode. So if you have a smaller electrode with the same amperage, you're going to have a higher current density. If you have a larger electrode with the same amperage, you're going to have a lesser current density. So you want to use large electrodes for large muscles, small electrodes for small muscles. That just kind of makes sense. So in lab, you're going to have some small ones and some larger ones, and you get to decide which ones to use. The depth of the electrodes is going to depend, the depth of the electrical current is going to depend on the spacing of the electrodes. So you don't want the electrodes to be touching because then you're shorting the circuit. They have to be at least an inch or 2.5 centimeters apart. The farther apart you put them, the deeper the electrical current is going to go. So if they're closely spaced, you're going to get a more superficial stimulus. If there's more space between the electrodes, you're going to get a deeper stimulus. So in kinesiology, when we were talking about what's deep to what and what's superficial to what, this is why we wanted to know. Because we want to know what are the tissues underneath, what are we potentially affecting with this electrical stim. So one of the problems with electrodes I alluded to earlier is non-uniformity of conductivity, which creates hot spots and risk of burns. So it means it's not uniformly conductive over the whole surface of the electrode. This non-uniformity can be due to either the type of electrode and the site of conductive media in the electrode. So if you are using an electrode where you have to apply a gel or a water-soaked sponge, if you don't do it evenly, you could have non-uniformity and create hot spots, areas of higher current density. If the electrode is worn, the areas where it's worn, it's not very conductive, so the other areas are going to have a higher current density and the potential for burns or hot spots. Conforming to body surface areas, so like in this picture, the electrodes on a person's foot, feet are very convoluted. They don't have necessarily a flat surface to put an electrode on. You're going to have to make sure the electrode's touching down everywhere when you're putting it on a variable skin surface or an uneven skin surface. If you're using an electrode where you have to apply conductive gel, you want to make sure you have an even application of the conductive gel so you don't have areas with gel and without gel and create those hot spots. So that's a potential electrode problem if you have a worn electrode. If you have too small of electrode for a big muscle, you get too high a current density and you can cause burns. So just be aware of what you're using and why you're using it and the condition of your electrodes. So for electrical safety, we want to think about there are two different kinds of shocks, a macro shock and a micro shock. So macro shock, you can feel it. It's like getting, like static electricity. You touch a doorknob or something and you get shocked. That is a micro shock. It's a physiological, or a macro shock. It's a physiological response to a perceptible current. A micro shock is imperceptible, but if you got a micro shock on the surface of your heart, you could get an unwanted physiological response. So usually if there's a problem, you're avoiding macro shocks. So you want to make sure you use your electrical devices are grounded and you're using a grounded electrical outlet. You don't want to use those cheater plugs or anything and you don't want to use extension cords. You want to make sure that you're plugged in directly to a grounded outlet. If you're anywhere near a water source, like if your treatment rooms have sinks in them like ours do, you want to have ground fault circuit interrupter outlets, which are an extra margin of protection. The GFCI monitors for electrical fault and it shuts off the power to prevent macro shocks. So if that happens, if you set off your GFCI, you need to examine the appliance that you're using and you need to reset the socket. So in this picture, you see a GFCI and the reset button's right in the middle. It won't work unless you reset it. So you want to always use three-prong outlets, GFCIs. You want to carefully test all new equipment. Make sure it's calibrated annually. You never want to use two-prong cheater adapters or extension cords. You don't want to get electrical devices in contact with external cardiac pacing devices. You want to wear, rubber-soled shoes, insulatory shoes, especially in hydrotherapy areas. Any equipment that you suspect has a problem, you want to remove it from the treatment area immediately. You want to label it, red tag it, or whatever the procedures are for your clinic, and have it serviced before you use it on another patient. So electrical safety is important. Even though we're talking about really low amperages, we don't want to take the risk of hurting someone. So list of references, there's going to be another list of references in the strength training and pain management sections. So you can look through those references and in the PowerPoints and see what you think if you're looking for more information. Of course, there are lists of references in the books as well.